Okay, section 4.2, you see at the bottom of page 125, it kind of is a little bit of a typo or got misplaced, but that should be on the next page. But anyways, the title of section 4.2 is exponential functions. So there's a lot of exponential functions, but this one in particular, or these two in particular, they're the same, but if you follow these rules, you're going to have exponential growth. If you follow these rules, you're going to have exponential decay. It sounds a little confusing at first. That's why I wanted to take a little bit of time in a pre-lesson. I almost didn't, but I thought it would benefit us. Why not? So let's go ahead and build what's going on here. So this says A has to be greater than 0. So let's just make it a 2. I'm going to make that a 2. And how about B is greater than 1? Well, let's make that, well, we could make that a 2 also. So that's a possibility. And now, don't forget what this is. This is my y, and this is pretty obvious. My exponent is going to be my x. Now, I've already picked a few x's just to see what happens here. So if I actually plug this in right here, I'm going to get, I'll show my work right here, 2 times 2 to the negative third power. Well, that's the same thing as 2 over 8, which is 0.25. And so I go 0.25. So I go negative 3, and then barely up, barely up. Now I'm going to put in negative 2 for here. So that would be 2 over 4, which would be 0.5. And so I go negative 2, 0.5. And now we keep going, so 0.5. Now I'm going to put negative 1 in for here, which would just be over 2, which is now 1. So I have 1, negative 1, 1. You can kind of see what's happening. And now I'm going to put 0 in for x. And I hope you remember, anything to the 0 power is 1. So this would just be 2 times 1, which is 2. So the point 0, 2, right there. And I want you to notice something. If x is 0, won't this always be a 1? And therefore your y value will be a, because that's where the a goes. Remember, this is a, b to the x. Keep that in mind. That's going to be significant for one of our problems in the packet. But once again, when x is 0, it's going to cause this to be 0, or excuse me, it's going to cause this to be 1. So therefore, when x is 0, your y will equal that, your a, okay? Which is your y-intercept, by the way. Okay, so if I put 1 in for x, look at what happens. 2 times 2 is 4. So now this is 4. So I go 1, and then I go up 4. And if I put 2 in, now I got, well, I can just do this. So I get 2 times 4, which is 8, and I'm off the chart. So I'm way up here. You can see that this thing, and by the way, if I went way out here, and I went 1, 2, 3, 4, 5, 6, 7, negative 7, and I put it in there, look at what would happen. I'd get 2 times 2 to the negative 7 power, which would be, now I don't even know what that is, I should, but 2 times 2 times 2 times 2 times 2 times 2, how much is that, 6? So that's 4, 8, 16, 32, 64. So that'd be 2 over 128, which is 1 over 64, which just means it is barely above the x-axis. It will never go under it, because it will always be just getting smaller and smaller. But this comes in like this. And then if we think in terms of left to right, what do we have? We have growth. Okay? Now, if you go into business, and this is the way you start bringing in money, I think you got a good business plan. If you don't have a growth like this, something's up. You better recalculate, maybe a new career, or maybe you're doing something wrong. Think about that, life application. Okay. See, teachers don't have to worry about that, because what does our income look like? Like that. You see? So we're in it for the joy, not the cash. Anyways, let's go into this one. So exponential decay, what's this mean? All that means is B is going to be a positive fraction in between 0 and 1. What's this? And when I say fraction, I mean like 2/3 or 1/7. Because you could say like 10/2. All right, no, it's a fraction less than 1. So a is greater than 0, that just means something positive. So but now let's go like this. Let's build something. So I'm going to build one. F of x equals, let's pick something greater than 0. I'll just go with, I don't know, 3. And then b, let's make it easy, 1/2 to the x power. See, this is by definition an exponential function, but it's exponential decay. Why? Because this is a fraction. Well, why would that make it decay? Watch. So now I'm going to do less. -2, -1, 0, 1, 2, and just kind of watch what happens. So if I put -2 in here, and I put it right there, I'd get 3 times 1/2 to the -2 power, which would just be 3 times 4, because you flip this and then square it, which is 12. So -212 would be way up here, even higher than that. But then if I put -1 in, now you would just flip the 1/2 and it'd be 2, so it'd be 6. So -1 is 4, 5, 6. And then 0, remember, if I put a 0 in there, that just makes this 1, and my answer will always be the A, so that'd be 0, 3. And if we keep going, put the 1 in, well now 3 times 1/2 is just 1.5. So it'd be 1, 1.5. And then the last one, put a 2 in there, would be 3 times 1/4, which would be 3/4. And so I go all the way over to 0.75, I go over to 2, and I go up 0.75. You can see what this is doing. It's coming through here, and it's coming like this. And the bigger this number gets, we go 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. You see, then we're going to get a smaller value, but it will never be negative. And so it's just going to continue like this. And yeah, this is an asymptote, but that's exponential decay. All right, so there's a nice little warm-up for you, and you're going to be asked to manipulate graphs based on your rules from first trimester and second trimester. So let's just dive into that.